We finished step 1 and selected an algorithm to accelerate. Now let's get access to the development environment before we continue with step 2 and pick a snap-enabled card. There are 2 different environments for this workshop. The development tools run on a development system in the cloud. We will later deploy the example application on a Power 8 system that is also in the cloud. The development environment that we are going to use is installed on the cloud in a Jarvis application. All we need to access that environment is a browser. First, sign up for a Jarvis account on the NIMBIX cloud, saying that you would like to access a Power FPGA hardware. Then open the Jarvis platform at mc.jarvis.com in your browser and log in with the user ID and password that you got from NIMBIX. Once logged in, there is an application CentOS Snap Desktop on the compute screen. Click on this icon. In the window that appears, click on the Educational Environment button. Keep the setting of 2 cores on the next page, then hit Submit to start the application. You may have to agree to the end-user license and confirm the API key usage. Then you will see the CentOS Snap Desktop application start. This may take some seconds. Press the browser reload button if nothing seems to happen. As soon as the desktop is ready, click on the message saying, "Click here to connect" to get to the desktop. For a brief overview of the Snap GitHub pages, let's browse them now. Click on the NIMBIX icon at the bottom left, select Internet, then Firefox, and enter github.com/open-power/snap. These pages contain all information required to get started with your own system, and also the steps we prepared on the NIMBIX cloud already. Please take a minute to scan through the README headlines now. You may come back at any time to read the up-to-date information in the README and documentation files. Please also have a look at the linked documents, like the hardware README file in this case. On the NIMBIX cloud, we can now set up the Snap build environment. In the slides, all boxes with a black background are commands to be executed by the user. These commands are also in the README text on the cloud desktop. This slide lists the commands just for reference. We will now run them live. We are now ready to download the Snap repository and set up the build environment. Click on the CAPI Snap terminal on the desktop. For simpler typing, all commands are in a file readme.txt as well for easy copy and pasting. So it's a good idea to open that file as well. the git clone command downloads the snap code repository. Git checkout makes sure you are using the latest branch from that git that is supported on the NIMBIX cloud. The PSL simulation environment is already downloaded to the system. The PSL design checkpoint can be downloaded from the IBM CAPI portal. Here on NIMBIX it is also downloaded already, so the snap environment just needs the path to this file. Therefore, change to the snap subdirectory and copy the file snap_env.shell that is already prepared in the home directory. Once we had a look at the card selection, we'll return here to start the snap configuration tool and set up snap with the desired card, interfaces and example action. The next step in the process is to choose an FPGA card that fits your needs. With CAPI Snap on Power 8, we've enabled two cards so far: the Nallatech 250S, shown on this slide, and the AlphaData KU3 card, which we will describe on the following slide. The key factors when choosing a card are the FPGA characteristics and the card features, such as on-card memory, storage and SFP cages for fiber channel storage and Ethernet. All Power 8 cards are attached to the server via PCI Express Gen 3 for the CAPI connection. As we move forward to Power 9, we will have CAPI cards that attach via PCI Express Gen 4, as well as the OpenCAPI interface. At the center of the pictured Nallatech card, we have the Xilinx Kintex UltraScale 60 FPGA with over 3 MB memory on the FPGA itself and over 300,000 lookup tables to hold your logic. This card is used in IBM's Neo4j, Redis and Cassandra flash solutions, where these applications utilize the 2 TB of on-card NVMe. The card also has 4 GB of DRAM memory that can be used by the CAPI Snap action. When used in CAPI Snap mode, actions can be offloaded from the processor, but more often would provide filtering or other actions on data flowing into or out of the 2 TB of NVMe. At the center of the pictured AlphaData KU3 card, there is also a Xilinx KU60 FPGA. This card, however, has 2 memory DIMMs with a total of 8 GB of DRAM for local storage and 2 SFP Plus connectors, each capable of 40 Gigabit Ethernet. This card is commonly used for offload paradigm work, and with a future AXI to Ethernet bridge, it can also handle storage and network activities under the ingress, egress and funnel paradigms. We can now use the menu-driven Snap configuration tool to configure the used card. We start it now. Note the available I/O options change depending on the card selection. Selecting a specific action may also enforce SDRAM or NVMe interfaces. When we select the HLS NVMe memcopy action, it will require SDRAM and NVMe. Conversely, this means actions which depend on the NVMe interface won't show in the list of action types if the NVMe interface is not available. So, if we now change the card type to the AlphaData KU3 card, which doesn't have NVMe, the action type will change as well. Depending on the available card type in the cloud, select the appropriate card. For this education module, that means select the Nallatech N250S again here. Also make sure the Cloud Build menu item is selected. As soon as we switched back to the Nallatech 250S card, the Enable NVMe option became selected again. However, for this hands-on exercise, we need the HLS Hello World example action, so let's select it here. For the simulation tool in the cloud setup, choose between simulating the design with Xilinx XSim or not simulate it. That may be useful to just build and test an FPGA image. For the non-cloud setup, you could also select Cadence iRun as simulation tool. Then exit the configurator and save the new configuration. Please don't save the configuration to a different name.